Welcome to the HBM Test and Measurement FAQ video series. Hi, I'm Bart Morick, HBM Applications Engineer, and in this video I'm going to provide a short description on how to read the datasheet included with your shipment of strain gauges. When ordering strain gauges from HBM, you will receive a datasheet that includes lots of good information that you'll need to understand when you're making measurements. Keep this datasheet in a safe place, even after the gauges included in it are successfully installed, as you may need to reference that information provided. In this webinar, we will discuss the form in detail and explain what each of the values are and what they mean when making measurements. A package of HBM strain gauges contains a lot of information that is useful to you, the user. Understanding the information provided is critical in getting the most out of the data that you capture with our gauges. Each package contains basic information about the gauges included and more specific information that you will need to reference to properly use in order to convert the change in resistance measured into data from your project. The information is as simple as the resistance, the orientation of the gauge, and the maximum recommended voltage to supply the gauge with. The gauge packaging also includes more important information that is needed, such as the gauge or K factor, the temperature coefficient, and information as obscure as the foil lot and the production batch. Over the next few slides, we will go through all of this. The strain gauge package comes with some generic information. The order number provides the part number required to order replacement gauges. The type provides the size of grid in millimeters of the gauge. The general resistance of the gauge and the HBM orientation designation, along with the coefficient of thermal expansion value that indicates what type of material that the strain gauge is matched to. The maximum RMS bridge excitation voltage gives the user the voltage that can be used to power the Wheatstone bridge without burning the foil in the gauge. The foil used in the strain gauge is extremely thin, typically 4 to 5 micrometers. There is only so much current that can be run through the gauge without the gauge self-heating or burning out. This value is a recommendation, and the user should consider the material that the gauge is attached to when picking out an excitation voltage. For example, a plastic material is a less effective heat sink than steel, so a lower excitation voltage should be considered when using plastic as opposed to steel. Each strain gauge batch is tested using a precise load to determine the gauge factor. The gauge factor is the ratio of relative change in the electrical resistance to the mechanical strain, typically a value of approximately 2 in a metal foil strain gauge. Transverse sensitivity in a strain gauge refers to how the gauge responds to strains that are perpendicular to the primary axis that the gauge senses. In the ideal world, it would be preferable if the gauges were insensitive to these transverse strains. Each pack of strain gauges contains a plot and a multipoint or order polynomial that describes the amount of thermal strain that can be expected over the operating temperature range of the strain gauge. The plot shown here covers a span of temperature from minus 10 degrees C to 120 degrees C. The generic specifications for the Y series gauge indicates that the actual temperature specification for the gauge is from minus 200 degrees C to plus 200 degrees C. So, if your tests are outside the plotted range, you can use the polynomial equation to correct for any temperature-related effects. The temperature over time of the test needs to be recorded so that you can correct for that using your analysis software package. Two items on the datasheet that are often overlooked are the foil lot and the production batch numbers. Creating the foil from which strain gauges are manufactured is a very labor-intensive process, and it is critical that users are guaranteed consistency when using gauges. All the gauges within a single package always come from the same shipment of foil so that the specifications always match. In cases where a customer requires large numbers of a single type of gauge, the need to be able to say the production of those gauges was made from the same foil lot and production will allow them to be confident that their gauges are traceable and consistent from gauge to gauge to gauge. With this information, the customer can always come back to HBM to find out when their gauges were made and to be confident that all the gauges were made at the same time and have the same specifications. All the information for the specifications on the individual strain gauge package is embedded in the barcode included on each package. Using a commonly available QR app on your phone, you can quickly scan the barcode and read back the published specifications for the gauge in that particular package. The values are then separated so that the information can be imported into your setups or analysis packages to prevent the possibility of mistakenly entering the data incorrectly. So in conclusion, the datasheet for your strain gauges includes lots of good information for your reference. Please keep it in a safe place for future reference, even after the gauges are installed, so that you can go back and get the information that you need. Thanks for watching. And if you have any questions, please feel free to call, email, or visit our website for the latest product solutions and downloads at www.hbm.com.